These are the lesson 13.5 notes on the cosine function. Today we're going to take a look at graphs of the cosine function. We'll analyze parts of the graph. And we'll also solve equations using the graph of the cosine function. The graph of the cosine function is a wave function, just like the graph of the sine function was. And both the cosine and sine graphs have amplitudes of 1 and periods of 2 pi. So you may recall when we worked with the sine function the other day, the sine function starts kind of here at 0, 0. It goes up to 1, down to -1, and back up to 0 when we hit 2 pi. What it basically models is what happens on the unit circle with the y coordinates as you move in a counterclockwise direction. So we've got our circle down here. As you move around the circle in a counterclockwise direction, the y coordinates start by going up, then down, further down, and then back up again. So the y coordinates go up, then down, and then kind of back up again to 0. The cosine function models the x-coordinate around the unit circle as we move in a counterclockwise direction. So as you move around the circle in a counterclockwise direction, the x-coordinates get less and less as you move to the left. So the x-coordinates are getting smaller and smaller and smaller until you get halfway around the circle, and then the x-coordinates become bigger and bigger and bigger and more positive as you move to the right. So they start by getting smaller and smaller. They go from 1 to 0 to -1, and then back to 0 and back to +1. And that's modeled on this graph. The graph starts at 1. The x-coordinates get smaller and smaller until you get halfway around the circle. Then once you get past the halfway point, they get bigger and bigger until you get back to 1 again. So you can see on both of these graphs, for example, the cosine graph, here's one cycle of the cosine graph right here. It has an amplitude of 1 because that's the distance from basically the middle of the graph to the top is 1. And the period is equal to 2 pi because that's the length of one of these cycles. On a cosine graph, this cycle kind of resembles a sideways C, whereas on the sine graph, one period of the graph sort of resembles kind of a sideways S. And if you think of cosine starts with the letter C and sine starts with the letter S, that kind of helps with talking about the shape of this graph. The initial value for the cosine function is 0, 1. That means at 0, that's typically right here is our initial value for cosine. The sine function, it's at 0, 0. But both these graphs repeat cycles every 2 pi. They're both cyclical graphs. They're both wave functions. Many of the same rules apply to the cosine function as they do the sine function. So you may recall a formula we worked with the other day, which was y equals a times sine of b times theta. Today we're going to be looking at y equals a times the cosine of b theta. Again, the absolute value of a is the amplitude of the cosine function. B is the number of cycles the cosine curve completes in the interval from 0 to 2 pi. And theta is sort of like our x variable. It represents an angle measured in radians. In addition to these facts, the period of a cosine graph is equal to 2 pi over b. When you write an equation for a cosine function, let's take a look at this first graph. We're going to start with y equals. And the first thing we want to talk about is the amplitude of this graph. You can see the graph starts here. At 0, 0.5, it goes down to -0.5, and then back up again. The amplitude is the distance from here, kind of the center of your graph, straight up to the highest point, and that distance is 0.5, so that's going to be your amplitude. We're going to use positive 0.5 because on a cosine graph, if the initial value is positive, we can basically think of this a value as being positive as well. And we're going to do cosine. B is the number of cycles the graph completes between 0 and 2 pi. So you can see on this graph, the graph is completing a number of cycles. So here's one cycle right here. There's 2. There's 3. There's 4. The graph completes 4 full cycles between 0 and 2 pi. So our equation is going to be y equals 0.5 cosine 4 theta. Another way of figuring out what b is equal to is the period is equal to 2 pi over b. You can also find b by taking 2 pi divided by the period. And in our first example, to figure out what b was equal to, you could have taken 2 pi and divided by the period. The period of this graph, it looks like it repeats every half of a pi or pi over 2. And if you take 2 pi divided by pi over 2, that's the same thing as 2 pi times 2 over pi. Pi's cancel and you get 4. That's your b value. What I'd like you to do is pause the video and see if you can come up with the equation for this other cosine function. So for our equation, we're going to start with y equals. The amplitude here is clearly equal to 1. That's the distance from kind of the midpoint of our graph to the highest point. That's 1. It's going to be a positive value because the graph starts at a maximum value. So we do 1 cosine. To figure out what b is equal to, we want to count the number of periods between 0 and 2 pi. This graph, it's kind of hard to tell because it's listed not in terms of pi, but in terms of regular whole numbers. So where is 2 pi? Well, it's about at 6.28, which is about here. It's kind of hard to see. It looks like the graph completes definitely 1 full cycle, maybe 1.5 full cycles. But what exactly is this value here? Well, we talked about the alternative way of finding b by taking 2 pi over the period. And the period of this graph is 4. That's the length of this cycle from here to here. So we can write our b value is equal to 2 pi over the period, or 2 pi over 4. So you could write that for your b value, or you could reduce 2 pi over 4 to pi over 2. And if you do calculate what pi over 2 is equal to, we do get that value that's pretty close to 1.5, which we had talked about earlier. So that seems to match up pretty well. So now let's take an equation and let's see if we could figure out the period, range, and amplitude based on this equation that's been listed here. If you're looking at the equation y equals 2 cosine 3x, there's a few things that we can immediately start with. I like to kind of sketch out what a picture of this would look like, and we know for the cosine function, the first value is going to be dealing with the amplitude. So here's a function that's going to have a midline at 0, and it's going to go up to 2 on the vertical axis. It's also going to go down to -2 on the vertical axis as well. Cosine functions start at a maximum value, so it's going to start here. And then the 3 means the graph is going to complete 3 full cycles between 0 and 2 pi. So if we put 2 pi right here, the graph is going to have to make 1, 2, 3 full cycles between 0 and 2 pi. So it's probably going to look a little something like this. I'm going to plot my maximum and my minimum points, and it's probably going to do something similar to this graph right here. Now, what we're going to identify are these 3 characteristics. First of all, the period of the graph, the length of one cycle. That's this distance right here. Remember, to find period, one thing you can do is take 2 pi over b. So that's what we'll actually calculate here. And because b is the value before our theta, or x value, which is 3 here, our period is equal to 2 pi over 3. That would actually be the fraction value that is right here on our graph, 2 pi over 3. The range of the graph is dealing with the y-coordinates. What is the interval for our y-coordinates? Well, as you go from basically negative infinity and work your way vertically, we can see that the lowest value is -2, the highest value is 2, and y can have any value between these here. So what do you write for the range? Well, we've got a couple options. One option is to use our interval notation, which basically says type in the left bound followed by the right bound. Because our y values can actually equal -2 or +2, it can be any value between here. Sometimes people like to write as an inequality with y. If you do that, you just give the lower bound on the left side and the upper bound on the right side. The amplitude of the graph is the distance from the center to the highest point. The amplitude is always a positive value. It's the absolute value of a, which in this case would just be equal to 2. Now, we can use graphs to solve equations as well. So we're going to look at a couple ways of solving cosine equations graphically. Let's start with the equation cosine of 2x equals 0.75 in an interval from 0 to 2 pi. What is this function going to look like? Well, let me start off with my horizontal axis right here. Draw a little vertical axis right here. We're working with cosine of 2x. Now, if you think of what would y equals cosine of 2x look like, the equation y equals cosine 2x is the same thing as the equation y equals 1 times cosine of 2x. So it'll be a cosine function that has an amplitude of 1. So we'll put like a kind of a 1 up here. And we'll put a -1 down at the bottom. 2 is the number of periods the graph completes between 0 and 2 pi. So that means our graph is going to have to complete 2 full cycles between 0 and 2 pi. So I'm going to put my maximum points here and here. I'm going to have minimum points halfway in between my maximum values. My graph is going to look something like this. That's for the left side of our equation. Now the right side of our equation, it says cosine 2x equals 0.75. To solve an equation graphically, we always graph the left side of the equation, which is this. We also graph the right side of the equation, which is this. Now the graph of 0.75, or y equals 0.75, is a horizontal line that does something like this. Now if you choose to graph this on your calculator, here's a few tips for good graphing. Number 1, if you're working with an interval from 0 to 2 pi, your mode should be in radians. So you want to make sure when you hit the mode button that radians is selected here. The second thing we're going to do is we're going to go to your y equals menu. And we're going to type in both sides of the equation. We're going to type in cosine of 2x, that's the left side of our equation. On the right side of our equation, we have 0.75, so we'll type that in as well. For your window, let's use the same window that we've been kind of working with just a moment ago here. Our x values are going to go from 0 to 2 pi, so that's all we need to write for your x min and x max. What should you write for an x scale? I'm not sure if it matters too much. I'm going to use pi radians for my scale. That shows how often I have tick marks. For my y min, I'm going to use -1 and +1 with a y scale of 1. That's based on what my amplitude is. When I graph this on my calculator, you should see the same graph that we just did by hand with our wave function followed by our horizontal line. To solve an equation graphically, we need to find the coordinates of the intersection points. Now this is where having a calculator is handy, and if you did this by hand, you're not really going to be able to get very good accurate answers. There are 4 different intersection points where you can see the curve intersecting our line. I'll draw those dots rather large right here. And what we need to find are the x coordinates for these values. We know the y coordinate is going to be 0.75, but what are these 4 x coordinates here? To find these, what we're going to do is we're going to go to second trace, and we're going to use the intersect feature, number 5. For first curve, you may want to kind of scroll your cursor until you can see your little cursor moving along your graph here. I'm going to go from left to right. You can see my first curve is on the wave function. I'm going to hit enter. And then for the second curve, I'm going to move my cursor right and left. You should be on the line. Hit enter, and then for guess, we're going to try to guess where the intersection point actually is. When you do that a few times, you should get an intersection value. Here it says it's 0.36 and y is 0.75. All I'm concerned about is the x coordinate of 0.36. So that's one of my solutions right here, is 0.36. We'll do the same thing for the next point, then we'll let you try out a couple. We're going to go second trace to find the second intersection point, back to number 5, intersect. For the first curve, I'm going to move my cursor a little bit closer to where the intersection point is, till I'm pretty close to it. I'll hit enter. Second curve, I should be on this line right here, hit enter, and then for guess, move your cursor close to the intersection point. Here I got an intersection value of 2.78, that's my second coordinate. What I'd like you to do is see if you can find the other 2 coordinates using the intersect feature on your calculator. To find the third intersection point, we go to second trace, we choose the intersect feature. First curve is our curve, second curve is our line. We're going to guess pretty close to that intersection point, and you should get approximately 3.50. For the second intersection point, we hit second trace again, choose number 5. For our first curve, we're going to scroll our cursor over here. So we're close to our intersection point. We hit enter. Hit enter again on the second curve. We try to guess close to an intersection point. And for our fourth point, we get 5.92. We'll write both of those values down. So for your solution, we're going to write down all 3 of these coordinates. X can equal 0.36 or 2.78 or 3.50 or 5.92. These are all valid answers. To graph the second function here, one quick suggestion. If you notice what the amplitude is, the amplitude should help you determine what you're going to use for y min and y max. So when you go to your window here, we're going to leave x min and x max alone because we're supposed to solve this equation in the interval from 0 to 2 pi. But you'll need to adjust your y min and y max based on your amplitude. So we're going to go from -4 to 4. What I'd like you to do is graph this function, sketch a picture of this graph on your worksheet, and see if you could find the intersection values here. We'll pause the video and see what you come up with. So the first thing we do is graph the left side of the equation, y equals 4 sine x, and the right side of the equation, y equals 0.9, and we show that graph on your screen. You can see that there are 2 intersection points, so there's going to be 2 solutions to our problem. We use the intersect command, second trace, to figure out where these intersection points are at. Here's my first value. It's at x equals 0.23 approximately. To find my second intersection point, I go back to second trace and use the intersect command. I hit enter for first curve, enter for second curve, enter for guess, and I get approximately 2.91. So I write my 2 solutions as x equals 0.23 and x equals 2.91. And today we worked a little bit with the cosine equation and a little bit with the sine equation in terms of its graphs and finding solutions.